We are in 4.5. Remember, 4.5 is that section that we started all together. And when we started it all together, I was fully intending to finish it with you live. Why was it not live? Because I had to leave after your unit circle quiz. So therefore, how were you supposed to finish this section? Video that is attached where? 4.5 homework assignment in Google Classroom, right? And I think one of them is a note one and one of them is an extra examples one, or maybe that's 4.6. Either way, it gives you the main information. So you guys had that, you were working on homework, and now we're to whatever is up there. Starting with 13C, where you guys have gotten stuck. Let me scroll down to wherever that is. What's 13C? We have a sinusoid. I'm going to grab a picture of that real fast and see what's weird about part C. If I look at this function, I see he's amped up to 4, up 4, down 4 from his middle, his sinusoidal axis, which has been shifted down 5. He also has a bit of a period change in the sense of pulling that 7 out. He's been squashed to where there are now 7 cycles where there was 1, so every cycle is taking 1/7 of the time. Inside is always backwards, what do you think? And he's also shifting to the right a little bit. Before I even get to C, I have to find a marker. You guys know what I mean, stylus thing. I would rewrite this. And I would rewrite this as I showed in practically all the examples. It's a sign, right? Yeah. In notes that you were supposed to watch. Guys, please. Okay. So I got to shift down 5. That's going to be my sinusoidal axis. He's amped up. That's what's multiplied by him. Up 4, down 4. That's the amplitude. I'm going to pull that 7 out, which is awkward. But as I'm showing my cute little Algebra 1 kids who are factoring out GCFs for the very first time, actually no. Now they're doing X methods for the very first time. That's what we're doing before we go on semester break. When you factor something out, when you pull something away, it's division. So if I'm factoring out the 7, I'm also dividing the 7, which makes everything a whole lot easier. Because what was there, 7x, well, that's nice. The 7 comes out cleanly. The pi, does the 7 come out cleanly? No, but no big deal, whatever. It's still just pi over 7. So I have this nice little boop-a-doop-a-doop-a-doop-a-doop-a-doop-a-doop. And I could graph accordingly. Now, hold on. You didn't ask for the whole thing. You asked for C. So let me go see what C... Oh, use function notation to...
This is mine.
Well, check what I just did, though, right? So now I've shown the shift. I've shown the stretch. I've shown that what they're saying is, what if you're trying to think of this only with transformations? You guys didn't like this back when we did this in section 1.7. They want us to write the transformed one. That's too close to whatever, same thing, right? They're saying, what if f is sine? And you're trying to write this as the transformed version of that. Then I could say, well, what's happening to f? Well, I have 4 times f of, and then I have 7 times x minus pi over 7, and then I have a negative 5. They might do this a different way. They might go ahead and put the 4 in front. They might even put that 7 right there. No, that's weird. F7. Sounds like Battleship or something, or a keyboard function. But we'll go ahead and see what they do. They could put that minus 5 at the end like they did in the beginning, but basically it's just the sign leaves and the f goes in, because that's the only part that's dealing with the parent function as far as all of those numbers. So they have an f. What's times the f? That's a 4. What's times the f? What's times the sign is a 4. Oh, they don't even have it written all nice and pretty. Okay, fine, whatever. Just leave it like that. Oops. You know what I mean. That. And then just keep your, ooh, it's not a plus, it's actually a minus.
That's what threw me off, because I was like, I knew it was like, I put
oh, but you thought it was.
And I was like,
yeah, they're just trying to show you. A lot of people with the minus think it's a reflection, like they think this means reflection, but it doesn't. It means down 5. Yeah. So when most people see the plus, they know it's a shift. That's what they're trying to do, I think. Does that make more sense, though? Yeah. Just make the negative 5. Okay, number 15. Was a little funny because they give you a picture and not an equation. But guys, according to what our different pieces are, P.S., if all of this is foreign, that just means you haven't done the work and watched the videos, so do that this weekend. But A stands for amplitude. Remember, amplitude for any sine or cosine. This looks an awful lot like a cosine. Anybody know why? Top to top to top to top, right? I mean, could there be a sine in here? I guess so. But it's a lot nicer to be like, oh, at the top, that's a cosine. Okay, cool. Remember, the amplitude is how high from the middle. That's A, which should be mimicked below. It's how far up the wave goes, and then how far down from at rest or from equilibrium. And then D is my shift. So can't we take the 5 and say we know how high? Can't we take the -1 and we say how low? So can't we know the whole distance, which is 6, and then can't we figure out the amplitude is going to be, well, how high, how low? That's going to be 3, right? From what middle? We'll come down 3 from 5. Aren't you going to be at 2? So now all of a sudden I know what the amplitude is, because it's up 3, down 3, from a middle of 2. I know my shift and I know my amplitude. Take your wave, top to bottom, cut it in half. Halfway is my equilibrium. And then my wave is going up that much, and it's responding by then going down that much. And if it was to level out, it would be at a height of 2. Questions? You look confused. We're okay? Just pondering deeply today. Number 16. What do we got? Oh, it's another picture one. You guys don't like these picture ones.
Isn't it just like max?
Oh, I was wondering why. Yes.
We'll take what we're... Oh, we didn't know why it was the negative. I mean, but do what we just did, right? So then, I mean, it's awkward, but what they're doing is they're saying that here's whatever, and they just kind of zoomed into where it is. So where is it? Well, it's going from here down to here. What did I just do? Cut it in half, right? So what's halfway between -4 and -8? 4 is way up here. 2 is way up here.
Wait, 6.
6 is way up here.
-6.
-6. Okay, that's okay. So that's our halfway point. So how high is the crest of our wave?
-3.
Well, just how high it is just 2, right? Because there's the top and there's the bottom. Is it just 2 and 2? No. But I'm just saying how high. How high is a absolute value sort of thing. So yeah, how high is a 2? And then it's been shifted down 6. But the problem is, what kind of cosine is this? Yeah, it's not a normal positive cosine, right? This one is a negative cosine. So then the how high, how low is 2, but when I go to plug that in, I also need to throw in, because this is like where the coefficient is, I need to go ahead and make that a negative amplitude. I need to put in my reflection. If I put in my reflection, then it's like, oh, there he is. Hello. And how do I know that? Because they do not allow for me. I could have had this be a positive. Check it. I could have had it be a positive if I was allowed to shift it over. I could have had a positive one there, or I could have had a positive one here if they had allowed me to shift it. But look at their equation, guys. There is no horizontal shift. So they said, as is, well, that cosine starting down, I need to have a vertical reflection in there as well. Does that make sense, Jackson and company? I heard you say first. The negative flips it?
Yes.
Cool. So then number 17 and then number 20, look at us busting it out. Oops, sorry. Oh, it's a calculator, God. P.S. Watch the mode. Wait. Watch the mode. It should be radians. If you're in degrees, ain't nothing gonna look right. If you're in degrees,
everything is like.
no. Yeah, no. But it just depends, right? But look, they tell you radians without telling you radians. If this was negative 360 degrees to 360 degrees, the sines, the cosines, the trig are being graphed on angle x-axes, aka angle axes. If these are the angles, that's radians all the way. So therefore, I get these two little guys. If you don't want a headache, make sure you're in radian mode, which I am not going to be until I fix it. What's that nice zoom that just reorients everything? Trig. Standard is if we're not doing trig. Trig says, is it radians, is it degrees? I'll make it nice. Oh, thank you. But hold on, I didn't even type in graphs. What do I need? I need cosine of x as my y1, and I need negative 1. Wait a minute. If we're just setting them equal to each other, can't we just think unit circle? Cosine is negative 1, cosine is the x, negative 1 at pi. I mean, I guess you could have. But they're trying to say, some of you are more visual, and it might be helpful for you just to think of, what's another way of knowing when cosine is negative 1? Cosine starts here, it's negative 1 when it's at the bottom. Okay, it's at the bottom at pi, because 2 pi, it's back up to the top. And it's at the bottom at negative pi. Some of you that have been struggling with unit circles and the ones and the zeros, if you know the graphs of sines and cosines, you can kind of figure out where, oh, it's negative 1 at pi, because that's halfway. It's positive 1 at 0. It gives you another way of thinking about it. But either way, it's going to be negative pi and pi.
What mode did you select again?
Oh, I saw this, so then I knew radians are my angle measure. And then I go zoom trig, because depending on it, if you're coming from degrees, it could be freaking out because it's not oriented correctly. Zoom trig says, you want radians, I'll give you radians. Let me show you what that means. It's doing numbers closer to pi and 2 pi, and not like 360 and 60. Sorry, negative 360 and 360.
May you demonstrate what happens
In degrees? If I just go right now without changing anything, it's like what? There's no wave. If I do zoom trig, it says, oh, don't worry, I know, you're dealing with like 90s now. 360s, they make it big for you. Now, if I was to go back to radian, this is where it freaks out. It's like, yay, it's all better, but that's way too big. 2 pi is 6.28. You're going to have it,
Whoa.
because it's just zoomed out so much. You see so much of your wave. Now, sine still only goes up 1 and down 1, so it's still good with the y's. That's the same. But with the x's, it's trying to do way too much. So if I do zoom trig, it says, oh, I get it. The numbers are smaller now. There you go.
Oh, what if you just put in the equation and then just press graph? That's what I did. It just gave the same line.
Did it give that whole like boom boom?
I just gave like a straight line.
Oh, did you see it up? It was up there a second ago. That was if I am in a radian window and I change to degree.
Yeah.
Why is that the way it is?
Yeah.
Because sine only goes up, or cosine only goes up 1, down 1. So cosine is at 1 at 0. But this is 1 degree, 2 degrees, 3 degrees. The change, the coming down to make the wave is so minuscule, like the pixel is too big. So if I was to zoom out and say, oh, I know it's supposed to be bigger. Let's go to, like 45 degrees. You'll start to see it come down. But I need it to go all the way. If I just go to 90, it's like, yay, I'm in the first quadrant. But to get that whole wave, you got to go all the way, to 360. And there again, this is taking an awful lot of time. Whereas a zoom trig says, oh, you need bigger numbers. I got you. You need bigger numbers. I got you.
Zoom trig.
Zoom trig. Zoom 7. Zoom 7. Zoom 6 is great if there's no trig. Zoom 7 is great if there is. We answered that question. Number 20. Am I going to answer all your 4.0? Oh, you guys are going to have me do the Ferris wheel one? This is the most fun. It's interesting. And it gives you a practical application of how a wave can model a circle, which is kind of crazy. Waves and circles and triangles, they're all interconnected. Ferris wheel. You would think to model this, all you need to do is just go around and around and around and around. The problem is, you have no idea where a person is at a certain place in time. All you see is a circle. It's like, where's the person? I don't know. Somewhere in the circle. But if you know, well, let's not make it too complicated. If you establish some sort of point on the circle, And then you start actually following that thing as it goes around the circle. And if we take this motion over to an axis where we have something like time changing and the person's height off the ground changing, what was originally just a point on a circle is going to become a wave. And people who are talking, let's learn to whisper, because right now we're kind of failing at it. You're cute still, but shh. Okay. Well, that just got much more extreme. If the person was starting in the middle and going up, then it would be a sine curve, because that would be starting at 0 and then going positively in a counterclockwise position. If the person was starting at the top of the Ferris wheel, then that could be a cosine curve. However, where do most people start in Ferris wheels? They get in at the bottom, and then they rotate, and that would actually be a negative cosine. But anyway, they're not asking us to actually build the model. They're actually saying, hey, guess what? We built the model for you. Use this. So what they give me, they gave me a sine curve. That sine curve, oh, actually, it looks pretty stinking good, except I would pull that b out of there. Come on, be better than the Algebra 1b, kids. If you factor, what are you doing? What operation? Dividing. And when I divide this guy by, pulling out what I need, when I divide, that one's great. And I just end up with a t. But when I divide this one, ooh, cool kids, how do I divide fractions?
Flip and multiply.
Take the first, well, let's not even write the division. Can we just say we know how to multiply by reciprocals? So I'm going to end up with a nice little t left over, minus, and then that whole thing becomes a nice little 11 over 2. And I can break this guy down however they want me to. So when they ask me in letter A to do something like the period, I say, oh, there's a formula for that. Period says, ooh, you guys should know this formula. What is period? 2 pi over b, or 2 pi divided by b, which is the same thing as 2 pi times the reciprocal of b, which would be 11 over pi, which would be, hey, every 22, they're going to make it all the way around the Ferris wheel. If you're trying to figure out how long to make the ride, at least get them around a few times before you cut it off. It's going to take 22 seconds to get around this Ferris wheel once. What else? That seems like it's going pretty fast. I think I might be getting seasick in that one. What does the period tell you about the ride? Okay, I just answered that one. Amplitude, how high, how low? Guys, remember, it's just whatever's multiplying and stretching your wave. Vertical stretch, 51. What does the amplitude tell you about the ride? Careful. It's not like the entire diameter. It's the height from the, you can think that equilibrium, but equilibrium of a circle doesn't make sense. Axis of revolution makes sense. It's the radius of my Ferris wheel. And then last but not least, they're asking me to graph it. And so to graph it, I mean, some of you might try to throw that in your calculator, but getting the zoom right could be disgusting. I would just look at it real fast and say, go up to 53. If you're on a Ferris wheel, do you actually want to hit the ground? I hope not. Don't you hope you're a little bit off the ground when you come down?
Yes.
So then when you go up 51 and go down 51, well, going down 51, sorry. I showed 51. 51 plus 53 would be, what, 104? Is how high up in the sky you get. And then minus 51, you're going to go down to 2. And this is a sine curve that's being shifted. You're going to the right. I'm just going to put 11 over 2 just because. I know somehow it's going to do this. And so then it's going to come over here. I just don't know how long it is until I apply my 22 seconds. So my 22 seconds, what is this? That's like 5.5. So 22 seconds, I can go ahead and add that to know when to end my sine curve. Like that, the end of my sine curve. It's not a negative, right? It's not flipped. No, it's normal. What's 5 plus 5 plus 22? That'd be 27.5. Then we can split that up to figure out our quarter cycles, etc. But I think that might be enough for us to figure it out. So I need something at 5.5 and 53, and then it goes to be a sine from there. So 5.5 and 50, no. 5.5, what? No. 5 point, what? now? 5.5 and 53. Booyah, I got them. And oh look, it lets you get in at the bottom instead of taking like a ladder to get in the Ferris wheel somewhere higher up. That makes sense. Get at the bottom and then go for a ride. Woohoo! And then it ends at 22. Dun 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 dun. Those are all your 4.5 questions. And it's 9:04. So, 4.5 is done. Test corrections, if you have them, I'll take them. I'll be here until 1, if not maybe 2. I have to go get my puppy a pill and then possibly support the girls soccer if that's okay today. Anyway, and then come to the Sparkles tonight. But do you guys have any last minute questions before you leave? P.S. When's the very, 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 very last day for makeup work, missing work, corrections? So if you don't have them today, when's your deadline? Friday, December 10th, but the sooner you give it to me, theoretically, the sooner I can process, even though my life is crazy because I have all these projects due for my class on this week. But we'll see. I'll do the best I can. Gotcha.
And next week will be the week where we can retake the unit circle.
I mean, you can do that anytime, but yeah. You can retake the unit circle. All the way up to Friday, December 10th.
I got an 89.7. We'll let round 2
Ryan. If you guys have corrections, turn in. Go do it. Get it out of your life so that you don't lose them and then get automatic 0.
What?
Put a big 5 and get your water.
We have the next class together, it's fine.
No.
Alright guys, I'll see you later. Alligators after a while, crocodiles. I hear you. Let me stop my recording. Sorry.